design project. It has been posted on Canvas, so you have access to this. I would like to just run through it and hit the high points here. We've got a health research complex that's being built related to native cultures populations in North America. And this is funded by a bunch of organizations. Hypothetical problem, by the way, but wish it would be for real. And this will be a multi-story research center being constructed, and you are evaluating the suitability of 2 sites for such a center and such a building. And that would be part of the evaluation for cost of a structure and so on. And one site is clay soil and is located in Portland. The other site is clay, and the other site is sands, normally consolidated sands in Edmonton, Alberta, Canada. And the staffs associated with this are based in the respective countries. Therefore, you'll be utilizing English units in Portland and SI units in Edmonton. So the storyline of the problem is constructed that you're getting exposure to both sand and clay and English and SI units. So hoping that's good in terms of breadth for the experience. The proposed project involves a template design of a common foundation with the following: dead load and live load provided here. In geotech, mind you, we're just going to add those up and design for the sum. It's the structures part where we're going to add some nuance to that and apply factors to those loads. And you'll see that with the reinforced concrete design about the last week of the class. I hope we'll sneak it in, not the day before Thanksgiving. I have that slated for review, but the week prior to that, I would hope we'd be covering that example. And my intent here, as I've mentioned, will be learn by example on that one. It'll just be, you'll be running different numbers through the same process. We have a column which is concrete. It is square, 18 inch by 18 inch. Some of this is the structure stuff that's important. The steel is a yield strength of 60,000 PSI. And the concrete is in the column, 5,000 PSI strength and 4,000 PSI in the footing. By the way, it's quite typical that footings are made with lower strength concrete. We'll get to that when we get around to the structures part of it. And the depth of embedment is going to be 3 feet on this, or 0.9 meters. So you can just jump in and use the SI units when appropriate. They're nicely rounded off numbers, and use the rounded off English units when doing the US analysis. And what you're going to do is construct a design chart for shallow foundations for these 2 sites. It'll be 2 design charts, actually, 1 for each. And there's an attached figure we'll get to next. And you will evaluate settlement of a 1/2 inch, 1 inch, and 1.5 inch. And then for Edmonton, you'll be looking at 10 millimeter, 20 millimeter, and 30 millimeter. And it is expected that you'll develop 5 points per settlement curve and 10 points per bearing capacity curve for the design chart. And I think that'll come into focus when we see that. You'll use VASIC's formulation for bearing capacity analysis, so your spreadsheets will come in very handy on this. And the geotech, I'm going to update this. This is an old version. I need to change this number. I'm sorry about the typo here. These need updating to the new numbers. That'd be 110,000 pounds and the equivalent amount of kilonewtons. But just be aware, I will flip that out right after lecture. Out of that, so for sure it gets done. And you'll use a factor of safety of 3 for both cases. And you'll calculate 1D consolidation settlements using 3 4-foot sublayers of the clay. Probably what you've seen in CE 381 in terms of consolidation has been just treat the clay as one layer. And now that we're in as far as having stress distribution beneath loaded areas, you can gain appreciation that actually the delta sigma will change with depth. And subdividing that into little layers is actually beneficial because it allows you to assess that, hey, up top, you're going to have more settlement occurring, a greater delta sigma, in the middle, less, and down at the deep depths, even less. And ideally, then you'd have to partner with that, soil samples and consolidation tests going to depth. In this example, we only have one value for all the consolidation material, but in principle, that's what's at hand here. Is we're heading towards that use of 3 layers to refine the entire analysis. You'll be refining the stress distribution, by the way. We're going to assume no secondary compression takes place, so that will not come into play. And you'll be making settlement based on ultimate primary consolidation, good old settlement for foundations. You'll use Schmertman method for determining settlement of the Edmonton side where there's sand, and you'll use a 20-year duration for the long-term aspect of that. There's a creep term in Schmertman, and you'll see that has a duration associated with it. So we'll use a 20-year version. When the design charts are completed, you will use that to actually design the foundation for bearing capacity and for limiting settlements to either 1 inch for Portland or 20 millimeters for Edmonton. And you want to show the determination of the B on the design charts for both bearing capacity and settlement criteria. You want to show both. And after determination of the size of foundations, you'll provide structural details for the reinforced concrete footings. You want to indicate assumptions that you'll make in solving the problem and provide justification for such assumptions, if any are made. You want to show your work and at a minimum show an example calculation for each type of calculation made. So if you're running through and determining something 6 different times, I want to see it in a hand calc once, and that includes the basic analysis, a full-on, hand-drawn version of a hand solution of that. And you can say, hey, we use the spreadsheet to do the other 5 or other 9, whatever it is, and that's fine. But you want at least one shown for each site. And the output from spreadsheets should be precisely, or concisely, I should say, presented. And that would be reduced to 1 page per sheet for printing when appropriate, not just kind of a mess of stuff with, many pages. Just think about it a little bit of how you're presenting it and scale it accordingly to get that into a final report type format. The formatting here is going to be part of the grade, as you'll see. And data and charts should be tabulated and presented in addition to the chart itself. So you're going to have a design chart that looks something like this. And what I'm asking for in that last sentence there is that somewhere, maybe off to the side or in a table above or below it or something, the actual data that makes up this chart. Okay? And that is graded. You'll see a very detailed rubric being provided here a few pages out that we're about to get to. And that is part of the expectation. And when it's asked for, I will have some points associated with it. And, it stings when you miss stuff like that because it just says it right there. Boom. Hey, that's what's going on. Or that's what is required. And again, it's a simple thing in this case. You're just showing the data that makes up the graph, but you do want to have that. That's good engineering practice. So in this case, what you're going to have, this is just a typical design chart. This is out of the Caduto textbook, by the way. It's a nice coverage of it. We have a load for the foundation and the size that's required to hold that load. And we go through and solve that for bearing capacity. And I mentioned in the problem statement just about a page ago that you'll want 10 data points to make this curve, to make that bearing capacity curve. So you'll come in with different loads kind of around your design P. You know what that is, in this case, 110,000 pounds. So you'll have some that are below it and you'll have some that are above it, and come up with some representation of a design curve like this. And the idea is when you're done, you'll come in at your design load, shoot over here, and come down on that curve and say, hey, for bearing capacity, this is the size that I need. I need that thing to be 13 feet width foundation, or 4 feet, whatever it happens to be. And you just call it out and say that's what it is for bearing capacity. Similarly, you'll go through that for settlement. And it'll be consolidation settlement for the clay site. It will be Schmertmann method for the sand site. And you'll have 3 curves for each of them that are called out in similarity to what is requested in the assignment. And these require 5 data points per. And 5 data points is a low enough number that you can do a bunch of this stuff by hand. But also when you're getting around to iterating and so on, I will strongly encourage you to get into using Solver on the settlement side and make it quite a bit easier for yourself. I'm not requiring it outright. I mean, you can simply sit there and change load in the corner. For instance, you have a dummy load and it produces your calculations and so on. You get a delta sigma and all the Schmertmann stuff and so on. And then a settlement's going to show up somewhere else in your spreadsheet. And you can iterate that by hand. Just keep changing the load until you reach exactly the right combination of load, size, and settlement that results. But I will say that doing that with Solver would be much more of an elegant type approach and presentation, and I would encourage it. But I also don't want you pulling your hair out over, syntax and programming. If you're up against a wall on the thing, you can certainly do it by hand. And the number of data points being requested here is low enough that would be, okay, it'd be acceptable. But it's going to be a lot of work by hand. It'd be easier if you can program it in. So this is the main design chart that you will produce for each site. So you'll have one of these for Portland, one for Edmonton, and you will design for both bearing capacity and for settlement. And as it turns out, this is the one you grab. You take the worst case scenario, you take the bigger, and hey, if it works for settlement, it's also going to work for bearing capacity. It has to, it's bigger, so it will by default. The grading will be on the following items: technical details and correctness of bearing capacity analyses, 10 points per site. Settlement analyses are going to be 15 points per site. Reinforced concrete design down at 5 points per site. I'm not keeping that as a centerpiece of the class, but I do want it to be covered commensurate with about the lecture time we're spending on it. One full lecture or something like that. Documentation will be 10 points per site. And this is little stuff. This is your calculations, your data, the actual data making up those graphs. I already addressed that one. And the methods. Hey, what did you do? I mean, I want a little bit of storyline here in terms of, this is now the Schmertmann method being used. I don't just want numbers getting thrown out, but, a little bit, this is being assumed, and here's this and that kind of stuff and so on. And the overall presentation of the project, that's the general look and feel and how, if it's well tailored and so on. And correct, of course, will be 20 points. So the packet will be presented as a single PDF file this term because of COVID, and the following order should be followed. And I'm being specific here and want you to get used to this kind of requirement, because this is very common in any workplace where you know, if you're writing a proposal for some money or for a job, you're doing a bidding document, whatever you have, you end up with requirements that, hey, it must be on this kind of paper and it must be dated here, signed there, it has to be in this order, and so on. And while this might sound a little bit trivial, it is something that is extraordinarily common in workplace at any level. Whatever you end up doing, you're going to have requirements like this. So I'm trying to give you a flavor for that. And by the way, it makes it, I'll call it manageable to grade. I added this requirement after offering it some years without this and trying to flip through a 30-page report and try to find stuff, and it was very, very difficult. Everyone had it in a different order. This way, there is a commonality implied in each report. So you will start with the Portland site and have the design chart right out of the gate. So you'll just show that design chart and you'll indicate the design shown, that actual B that I had identified in that last graphic. You'll show the baseline calculations. This would be stuff like shear strength, weight volume relationships, anything else that comes, along those kind of lines. Baseline sort of stuff gets you in on, hey, here's the parameters we're working with. You look at the bearing capacity calcs, you want an example spreadsheet output, and you want tabulated data for those points that are going to be or were shown in the design chart, I should say. Settlement calcs with tabulated data. Reinforced concrete design calcs. A sketch of the structural design of the footing. I'll have a template for you to, just a cartoon image that would be typical of this, and you'll see that a little later in the course. And that's simple stuff. A good version of this would be AutoCAD. An acceptable version, full credit kind of thing, would be a nicely drawn sketch with drafting tools and so on. If you're starting to get into just a hand thing on your knee while your roommate's driving you around or something, that may not do it. It should be a proper, dimensioned kind of graphic. And then I also am asking here in both of these sites for you to have a very brief comment, and this will not be worth a whole bunch of points, but I'm including this for awareness, cultural awareness. I think that is an issue that we're struggling with as a country. I mentioned this on Monday's lecture with, jazz piano player Takahata Uno being beaten and, world of hurt. And I think it was just during that lecture or thereabouts in Philadelphia, you had Walter Wallace Jr. being killed by the police. Another absolutely tragic situation, and happening way too much in America. Breonna Taylor, Stephon Clark, Trayvon Martin, on and on and on. It's a very, very long list. And I'm not going here for any kind of commentary or essays, but I think that having an awareness of cultural differences and cultural identity is important. And simply looking around Portland and saying, hey, what kind of indigenous or native cultures are there that would be served by this kind of facility? And the same thing with Edmonton in Canada. So it's a little side thing, just as a nod to some of this social unrest challenges that we're dealing with on a daily, weekly, monthly basis that doesn't seem to be going away. So just to make you think about that a little bit in terms of a new angle, maybe a different take on it, let's say, because there are certainly some challenges with native cultures as well. Edmonton will be the same set. Nothing new here, with the exception of the baseline calcs, in this case, having weight volume relationships, soil strength, and actual interpretation of the CPT, cone penetration test data, shown in your report. I need that in the report. And I'm being deliberate about this because this is one that I've seen missed numerous times, and I don't like taking off points, but it has to be in there to get the points associated with this. I think in the past I've had this aspect worth about 4 points, and that starts stinging. I mean, that's a, you know, a little notch of a grade getting to be. So I'll show you what I mean by that when we get around to the CPT data. And then the same stuff here that we saw on the previous site. The Oregon site looks like this. It is clay. Parameters given here. You'll notice here nothing about time rate of settlement. So you guys are actually positioned well to just jump into this and plow on through everything except the structural design of the foundations. This is the 12 feet that'll be divided into 3 separate layers. So there'll be 3 sub-layers of clay down here that get added together for the total settlement. We have impervious, incompressible bedrock down here. Water table consistent with base of the foundation. And a lab test was done establishing an unconfined compressive strength of 2600 PSF. So you can take that and run and get the C and phi and whatever your intent is on that regard. On the Edmonton site, this has sand, and there's some phase relation type stuff given here. A single direct shear test was done on that sand and some parameters given here. And the CPT test, looking like this, is available. And you're going to be simplifying this into layers of representative cone resistance in megapascals. And just as a example, I'll say something like this might apply. That would be a reasonable estimation for that layer. We're a little overshooting it here, we're a little undershooting it here, and saying this whole layer is about the same strength. And then you'd come back and get something like the next one. You'll see this in the Schmertmann technique, but you know, the next layer might be something like this, and so on. But it's your judgment on this, how refined you want to get. And it's not worth getting into 65 layers or anything like that. But I also don't want you coming up with 2 layers, because there's decidedly some variation here that you should be able to capture. And that is, by the way, a huge benefit of the Schmertmann technique, is it is based on CPT test, where it has this ability to refine your assessment of the soil parameters quite nicely with depth. And that's it for the packet that describes the design project. So are there questions at this stage? I'll stop the share for a moment.
Is this an individual assignment?
No, it's not. I'm just today deciding that, and this is upon weeks of reflection, I've been going back and forth and so on, of sizing of groups and this kind of thing. And I'd like to set it up where you set groups yourself, and I'd like to do that yet during this session. We still have 20 minutes left, and I would think it won't take that long. And I'll let you do your thing with cell phones and texting if you know people and want to work with them already. And if you don't, hang out and we'll make sure to get contacts made. But I would like groups of 2 or 3, and I'm fine with either size. And we have 19 students in here. So we do have a challenge where there's going to have to be some, you know, an odd number working on this thing. So we're going to need at least 2 groups of 2 given this framework. All right. So if you're into working as a group of 2, I'll say jump at the opportunity. If you instead want to work in 3, maybe start aligning with some others that you've met throughout the term, maybe through the spreadsheet breakout groups or otherwise, and we'll see where we end up here. If There are some folks that actually have alignment with saying, hey, we want to work together. I'm fine to set you into a group and get you into even a breakout room today. So you can, I'm guessing you'd have information, but just make sure you have a plan in place for, how this is going to unfold over the next month or so.
I have one more question. Did you say this is due on Tuesday?
No. That's homework 4. That's a homework that's been out there and assigned for a good long while. And I think I will make that Wednesday while I'm at it, just in a nod to the election to not have any conflict with that. So this will be due right before the final. And then when I say that, I'd like it to be, I think our final's on a Tuesday. So maybe late the week prior. We'll see how things are going with, and that happens to be Thanksgiving. The timing is just miserable this term with Thanksgiving break and finals. It's going to be a rough session for academia, I'll say, at Cal Poly. But I'd like to get them before the final for your benefit that you've actually been through it. And I can assure you that if you're delivering on this design report, you will do just fine on the final exam. This is the whole course right here, boom, in one stop shopping, and it's rather comprehensive. So it will be a substantive exercise, but it will serve you extraordinarily well in prepping for the exam. I'll say that. If you get this done few days before the exam, you won't need to be studying all that much for it. Maybe a little fine tuning and tabbing out some materials or something, but the main concepts you'll be up to speed with in good shape. Are there any folks that have preference for working together? I can simply go with a random kind of selection. If that's the desire, but I figured I'd give you an opportunity to work with some folks that you'd be comfortable with, as this will be some hours spent together, most likely, or at least counting on each other to deliver components. And that's teamwork has its own challenges, let's say.
Would you like to know our groups now, or?
That'd be great. I'd love to knock them out during the session. If you are preferring to kind of do that offline, I could set a due date or something. But if we're able to do it now, it'd be great. I'd very much like to just leave today knowing that everyone has a group and we're in good shape, and you got everyone's contact number for within your group and so on, and emails, that kind of thing. And we have about 15 minutes left, so I feel there's enough time to do this. Let me know if that's not the case, if you're more comfortable with holding off on this.
I feel like if you open the chat function,
Yeah.
could put our
Yeah.
groups in there.